Hello, hello, hello. So, this question is actually adopted from 2012 India pre-regional mathematical Olympiad question. So this is a question which is kind of suitable for Form 4 KSSM and Maths SPM students um, because they actually study certs, which is a entirely new chapter in Form 4 at Maths. It's a good thing to learn certs because people in all syllabus, the students in all syllabus struggle a lot when they dealt with certs. But now, those Form 4 students these days are already blessed with learning cert techniques. So, speaking of techniques, we need to know some very special things about certs, which is about the nested radicals. This is the thing which is called nested radicals because when we have a cert inside a cert, well, the small cert, which is the cert B, inside the large cert, which includes the expression of A plus the cert B, this is called a nested radical. A nested radical can be expressed in form of the sum of the radicals, of two radicals at least, because we have two terms, A and B. We can have two expressions, two terms, two radical terms, logically maximum. Well, the technique when dealing with such nested radicals is to eliminate the square. Eliminate the root by raising both expression to the power of 2. Okay, like so, and hence you will get this thing. And then this is the first very important cert identity. The second one is when you have something like a fractional cert. For example, I give you here when you have a constant on the top, or any kind of a cert plus minus, for example, and then on the denominator we have a plus minus certs, and you can have the conjugate of a certs, which is the C minus plus D, which is used to multiply the both sides of the fraction. So I'm gonna try to C minus plus D, and then C minus plus D, and then you will get a particular expression on the denominator, which is because of having plus and we have a conjugate of minus, and because we have minus, then we have a conjugate of plus, and essentially we will get something like for example, they are just the same things. Consider just one side, not plus minus, just consider if you have plus, then you use a conjugate minus, then you will have C minus D, or vice versa. If you have minus plus, then you also have a minus. The difference between C and D. And on top there is kind of complicated. Then you just try to expand them, and you will get not something which is not as easy as C minus D. Okay, now, so these are the two techniques I'm gonna apply in this question. So just back to the question. You have the first, you have the fraction 1 over the nested radicals square root of 2019 plus square root of 2019 square minus 1. In this case, we can try to use a bracket to represent that they are just a number. And hence, you can just try to, show that they can become the difference between two radicals, and you will find the constants m and n, where m and n, they belong to the integers, because this is a mathematical competition, and hence we must have integers in order to get a very beautiful answer. So I would like to tell you what is the answer. Surprisingly, m and n, if you add up them together, which is stated in the question, what is the value of m plus n? M plus n equals to 2019. That means if you have any odd number, like for example 2011, you will still have m plus n equals to 2011. And you will later realize that not all odd numbers are applicable to this special thingy, to this very special identity. I will explain it very later. So I'm gonna have to try my best to to have some strategy list. Well, these are the two strategies that I just mentioned. Change the nested radicals into the sum of the squares, the radicals, and use the conjugate multiplication. So if you have plus, then you have minus, and vice versa. And well, we try to substitute the values of a. Well, a equals to obviously the 2019, which is this. And then b equals to the bracketed expression 2019 minus, square minus 1. And you try to expand this expression, okay, when it's power raised to 2, and you will get x plus y plus 2 times square root of xy, like so. And hence you will get, in this case, because I want to have radicals here, for the sake of comparison, I want to have something which is similar as a plus square root b. So I must allow this 2 to be fit inside the radical. So we can relate that 2 equals to the square root of 4. And well, square root of 4 times the square root of xy equals to just the product, the square root of the product. So which means if you have a square root of a times square root of b, then it equals to square root of ab. This is one of the most important surd laws, just a rule that you have to know. Okay, now, so we can compare with b to x for xy and a to x plus y. So we know that x plus y equals to a equals to 2019, which is the first equation. And 4xy equals to b equals to 2019 minus 1. Well, recall back that 1 is also actually 1 square. And we are right now, we're realizing that we are having this difference of squares. So there is a particular identity we can use, which is this one. And you will get this thingy here, and you will have 2020 and 2018. And I purposely factorized 2020 into 4 times 505 because I want to eliminate, I want to cross the 4 out, okay, on both sides, and hence I just get xy equals to 505 times 2018, which equals to this number. Okay, now recall back x plus y equals to 2009 from the first equation, and the second equation is b equals to 505 times 2008. And then if you just try to get the y in terms of x, then y equals to 2019 minus x from the first equation, and x times y, and you will get x times 2019 minus x, well, because you substitute y in terms of x, and then you just try to solve for x by equating this expression with this number. Okay, recall back xy, and then xy equals to this number, and then y equals to this one. Just plug in the y here. Okay, you will get this final expression, this one. Okay, and then you will have x equals to this number or this number, and you will get also y equals to this number and this number, or this number. Well, it means when you have this 1010, when x equals to 1010, then y equals to 1009. Similarly, when x equals to 1009, then y equals to 1010. It's just apparently a very magical number right now. You can just have to care about that the numbers between x and y are just interchangeable, okay, since they are only involved in addition and multiplication, so it doesn't affect the operation. The operations doesn't affect the results, okay, it doesn't matter. So you can use any number, okay, as long as x cannot be equal to y, because both numbers, if these numbers x equals to y, then this number must be a perfect square, and this is not even a perfect square. And just a small reasoning about like proving why x and y cannot be equal. Okay, so since the nested radicals, this one, are just in fractional form, so you just have to ignore the numerator and then write this nested radicals in the separated radicals. Okay, so we recall back x equals to either 1010 or 1009, but I would like to use 1009 for x and then 1010 for y. Okay, and then here is the question: how can we get our desired form, which is square root m minus square root n? Well, this actually hints us to use the second technique, the second strategy, which is to multiply the conjugate of these separated radicals. We have to use square root 1009 minus the square root of 1010 at the denominator side, not only at the denominator side, but also at the numerator side. Oops. And we can just obtain this expression. Okay, notice that this is the conjugate. I just used this one. Okay, and this is the result after you multiply with the conjugate at the denominator side, and you will get -1, and then this still doesn't turn into any number, because radicals cannot minus with the radicals unless they have unless they share common factors, and you can factor out the common thing, and you just minus with the real with the remaining numbers. Okay, but in this case we can't, because they do not share common factors, so we just leave it like that. And then, well, -1, well, any number over -1 will lead to the change in the sign, which means you have plus here and you have minus at the square root of 1009. So as a result, the entire expression, which is this one, okay, from the beginning, equals to the difference of the square roots. Okay, difference between the square root 1010 and the square root of 1009, which is exactly same as the desired form. okay, which is the square root of m minus the square root of n. And what is the value of m? Obviously, m equals to 1010, n equals to 1009. And hence we can get the final answer, 2019.